Have you ever noticed that most things in space are round? Planets, stars, even moons, they all seem to prefer a spherical shape. It's like the universe has a thing for circles. But why is that? Why aren't there any cube-shaped planets or pyramid-shaped stars? The answer lies in a fundamental force that governs the cosmos: gravity. Gravity is like an invisible glue that holds everything together, from the smallest particles to the largest galaxies, and it plays a crucial role in shaping the celestial bodies we observe in the night sky. So, buckle up as we embark on a cosmic journey to explore the fascinating world of gravity and discover why round is the name of the game in the vast expanse of space. Imagine gravity as an invisible force pulling everything towards the center. It's like each piece of an object is being tugged inward simultaneously. Now, when an object gets really massive, like a planet or a star, this inward pull becomes incredibly strong. This immense gravitational force acts like a cosmic sculptor, molding the object into a shape where all points on its surface are equidistant from its center. And what shape fits that description perfectly? You guessed it, a sphere. Gravity's relentless pull ensures that no part of a massive object can stray too far from the center. It's like trying to build a tower with blocks that keep getting pulled towards the middle. You'll inevitably end up with a rounded structure. Now you might be wondering, if gravity makes everything round, why are there asteroids and comets with irregular shapes? That's a great question. The answer lies in the size and mass of these celestial objects. Smaller objects like asteroids and comets have much weaker gravity because they possess less mass. Their gravitational pull isn't strong enough to overcome the inherent strength of the materials they're made of. Just like a small pile of rocks won't collapse into a perfect sphere, these smaller celestial bodies retain their irregular shapes. Think of it this way: imagine you have a lump of clay. If you roll it between your hands, it'll eventually smooth out into a ball. But if you have a tiny speck of clay, it'll retain its original irregular shape. The same principle applies to celestial objects. Larger celestial bodies, like planets and moons, have enough mass and gravitational pull to shape themselves into spheres. This is because their gravity is strong enough to overcome the material's strength, pulling everything towards the center evenly. On the other hand, smaller objects don't have this luxury. Their gravity is too weak to mold them into a spherical shape, so they remain irregular. This fascinating difference is why we see such a variety of shapes in space, from the perfectly round planets to the jagged, irregular asteroids and comets. Understanding this helps us appreciate the diverse and dynamic nature of our universe. Our very own Earth is a prime example of a celestial sphere. Its diameter is roughly 8,000 miles, and gravity ensures that its surface is relatively smooth, with mountains and valleys only representing minor deviations. The Moon, our celestial neighbor, is another excellent example. Though much smaller than Earth, it's still massive enough for gravity to have molded it into a sphere. And what about the stars? Those twinkling balls of gas are also governed by gravity. Stars are gigantic balls of hot gas held together by their own gravity. The immense pressure at their core causes nuclear fusion, releasing the energy that makes them shine. This outward pressure from fusion balances the inward pull of gravity, resulting in a stable, spherical shape. Section 5. The impossibility of square planets. So, could there be a square planet out there somewhere in the vast universe? Well, it's highly unlikely. The laws of physics, particularly gravity, make it almost impossible for such a shape to exist naturally. Remember how gravity pulls everything towards the center? This fundamental force is what dictates the shape of celestial bodies. If you were to somehow magically create a square planet, gravity would immediately start working its magic. The force would act on every part of the planet, but the corners would be particularly affected. The corners of the square would experience the strongest pull, causing the planet to collapse inward. This process would be relentless and unstoppable. This inward collapse would continue until the planet achieved hydrostatic equilibrium, a state of balance where gravity and internal pressure are equal, resulting in a spherical shape. This is the most stable configuration for any massive object. In essence, gravity acts like a cosmic sculptor, smoothing out any irregularities and striving for a state of equilibrium. It's a fascinating process that ensures uniformity in the cosmos. And the most stable shape for a massive object under the influence of gravity is a sphere. This is why all planets, stars, and even moons are round, adhering to the universal laws of physics. Section 6. Gravity's influence on you. Gravity isn't just something that affects distant planets and stars. It's a force that's constantly acting on you too. It's what keeps you grounded on Earth and prevents you from floating away into space. Every time you jump, gravity pulls you back down. And the more massive an object, the stronger its gravitational pull. That's why you'd weigh less on the moon than on Earth, because the moon has less mass and therefore weaker gravity. Gravity is an essential force that shapes our universe and influences our everyday lives. It's a fundamental concept that helps us understand why celestial bodies like planets, stars, and moons are round. Section 7. Beyond our solar system. Our solar system is just a tiny speck in the vast expanse of the Milky Way galaxy, which itself is just one of billions of galaxies in the observable universe. And within these countless galaxies, there are trillions upon trillions of stars and planets. While we haven't directly observed every single celestial object out there, the laws of physics, including gravity, are thought to be universal. This means that the same forces shaping our solar system are likely at play throughout the cosmos. So, even though we haven't found any square planets yet, the search for new and fascinating celestial objects continues. And with each discovery, we gain a deeper understanding of the universe and the fundamental forces that govern it. Section 8. The shape of things to come. As technology advances, we're able to study the universe in greater detail than ever before. Telescopes are becoming more powerful, allowing us to peer deeper into space and observe distant objects with incredible clarity. Who knows what wonders await us out there? Perhaps we'll discover new types of celestial objects with shapes and properties we never thought possible. But one thing's for sure, gravity will continue to play a crucial role in shaping the cosmos. The quest to unravel the mysteries of the universe is a never-ending journey. And as we continue to explore the cosmos, we're bound to make new and exciting discoveries that challenge our understanding of the universe and our place within it. Section 9. The universe, a never-ending exploration. So the next time you gaze up at the night sky and marvel at the celestial tapestry of stars, planets, and moons, remember that gravity is the invisible hand shaping their forms. This force is not just a concept in textbooks, it's a dynamic presence that influences every aspect of our universe. It's a force that connects us all, from the smallest atom to the largest galaxy. Gravity binds the universe together, creating the intricate dance of celestial bodies that we observe. The universe is a place of wonder and awe, filled with countless mysteries waiting to be unraveled. Each star, each planet, each galaxy holds secrets that scientists are eager to discover. And as we continue to explore the cosmos, we're bound to make new and exciting discoveries that deepen our understanding of the universe and our place within it. Every mission, every observation brings us closer to unlocking the secrets of the cosmos. The journey of discovery never truly ends. With each passing day, new technologies and methods allow us to see further and understand more. There's always something new to learn, something new to explore. The universe is vast and ever-changing, offering endless opportunities for discovery. So keep looking up at the stars and never stop questioning the universe around you. Each question leads to new insights, and each insight brings us closer to understanding the grand tapestry of existence.